Another reason that we're so concerned with sulfur dioxide in the atmosphere, and also to a lesser extent nitrogen oxides, is because of their ability to react with water in the atmosphere and form acid rain. And the reason I have quotes around the term rain on the slide is because that acid can be deposited with rainfall that comes down, so the acid can dissolve into water droplets, but it can also come down as snow, or it can even attach to dust particles and be deposited with dust. This picture or diagram from the EPA's acid rain website is a very nice tool for demonstrating not only the sources of acid rain, but also the different ways in which acid rain is deposited into the environment. So in this slide we see nitrogen oxides coming from vehicle emissions and also from fossil fuel combusting electricity power plants, and then also sulfur dioxide. It comes out of primarily from coal burning electricity generating power plants. Once these are in the atmosphere, sulfur dioxide in particular is highly reactive, and it reacts with water to form sulfuric acid, which goes into raindrops and can be deposited onto the surface. And again, it can fall as rain, snow, or on dust particles. And then nitrogen oxides also can form acids when they react with water. Once these are deposited, they can either deposit onto land surfaces and interact with plant life, or they can be deposited onto soil and then washed into waterways as they travel through the soil into a waterway, or they can fall directly onto waterways, and this decreases the pH of that water body. When the acid gets into a river and a lake or onto plants directly, there's a lot of different things that happen, and none of them are really that good. They're all pretty nasty. So in this diagram here, we see different aquatic organisms that would live in these impacted rivers and lakes, and the pH level at which they can no longer either survive and or reproduce. And so as you go down the list, you see some of them can survive at fairly acidic pH levels. So frogs, for example, and perch, and even salamanders, they can survive in somewhat acidic, well, that's pretty acidic environments. But snails can't really survive below a pH of 6. And just as a reference, pure water has a pH of 7. Okay, so how does it impact these critters? It impacts the function of proteins and hormones in the organisms, and such that they either don't reproduce or they can't survive. And it's especially harmful to younger juvenile organisms. Okay, so in plants, there's a number of different things that happens when they're impacted by acidic conditions or acid rain. The acid damages their leaves, which reduces their ability to photosynthesize and create sugars that build plant tissue. It harms their roots, and so then the roots are not able to take up nutrients. And then it also releases, it leaches out, that's the term we often use, leaches out harmful chemicals that happen to be in soil systems, and so then it can expose plants to other toxic chemicals, so particularly metals that are present in the soils, and that's a double harm. So it harms them from the acid directly, but also from metals and other chemicals they get leached out. So what are we talking about when we talk about acid rain? Acid rain has a pH of around 4.3, and pH is a logarithmic scale. So that means we said pure water has a pH of 7. Seawater is more basic, has a pH of 8. Clean rain, because it has carbon dioxide dissolved in it, it is slightly acidic, and so it has a pH of 5.6. And natural bodies of water tend to be in the 6 to 7 range. But acid rain has a pH of 4.3. So when I say that it's on a logarithmic scale, that means every time you change the pH unit by 1, you're changing the concentration of hydrogen ions in that solution by tenfold. So when you go from 7 to 6, there's 10 times as many hydrogen ions. From 6 to 5, there's another 10 times. So from 7 to 4, that's 3 orders of 10. So that's 1,000 fold difference in the concentration of hydrogen ions as you go down that pH scale. And so acid rain is very acidic. It has a lot of hydrogen ions in solution.